Hello and welcome back. This is the final panel of Anomalies in Modern Astronomy Research, an SSE online symposium. My name is Annalisa Ventola. I am the editor of Edge Science magazine, and I'm pleased to bring Beatriz Villarroel, Dr. Beatriz Villarroel, back to the stage. Beatriz was the program chair of this fantastic symposium, and I'm going to let her close it out with the panel. So go ahead and take it away, Beatriz.
Okay, so I'm going to introduce 3 questions, and I will let each speaker to present their point of view, and then let's see where we land after each question, depending on convergence or not. Anyway, so the first question I have is, because we heard a lot about dark matter and problems with dark matter today. So should we really keep searching for dark matter, for example, like build bigger colliders, or just inserting so much money into dark matter research in astrophysics? Now, we are not particle physicists, but I mean, in general, both particle physicists and astronomers. What are your opinions? And maybe we can start maybe with Massimo.
That's not really my field, but I think we should, it's not my field at all, but I think we should measure the rotation curve of galaxies more, and to see how is the rotation curve of galaxies at high redshift. Do they repropose this anomaly in the rotation curve that we see here around? What is the changement of the rotation curve deviation from the Keplerian motion when we look at the Z equals to 7, for instance? This is something that is coming to my mind. All the rest would be done with a Large Hadron Collider, hoping that they find something in the, particle version of dark matter. It's very interesting, of course, but it's not my field. So Professor Kroupa would be more expert in this.
So maybe we can hear Professor Kroupa's reply on this.
Well, my answer will of course be no. I mean, if something is falsified, it doesn't exist, and there's no point in searching for it. I mean, I wouldn't, as a scientist, I wouldn't claim the existence of dark matter is falsified with more than 5 sigma confidence if I thought there was some remaining amount of doubt. I mean, it just doesn't exist, and nothing will be found, and there's no point in spending taxpayers' money for searching. I mean, if a private company wants to keep searching for dark matter, they can do it, but not taxpayers' money. I mean, that's just too valuable.
Mm-hmm.
Martin?
Basically, I agree Pavel's opinion. I think it was already a long time trying to find something for 3 or 4 decades. The limit of how long should we insist in finding these particles is an economical limit. Now the experiments are becoming more and more expensive, and the amount of money for science is not infinite. So sooner or later we should stop, just for a question of distribution of funds. Otherwise, we are going to put all the funds of astronomy in searching for dark elements like dark matter, dark energy, and there is no money for doing other kinds of less policy of science should take into account this. Possibly, if we insist in trying to find dark matter, maybe in 200 years we can find it, but it's not a question of patience, it's a question also of being pragmatic. There are other priorities in science too.
Well, I would just maybe add, I thought I understood that you just said, Martin, that maybe in 100 years they will find dark matter or something like that.
No, I have no idea. It's just a speculation. I'm not favoring dark matter, but imagine, let's assume for some minutes that they are right and there is dark matter. It's a possibility. I do not bet on that, but even so, if there is dark matter, how long time should we pursue this goal? We have reached a limit of energy. We can go to another limit of energy. For how long are we going to insist in the question? I think the question is also an economical problem. The limit is the limit of money that we can spend in the particle accelerators.
Well, I mean, if I were to ignore all the falsifications such that the possibility of a dark matter particle existing, then one should search for it, obviously. And then, of course, there will be an issue of cost. So extremely expensive experiments will not be able to be constructed. However, given that it's been falsified, it doesn't exist, and therefore there is no point in searching for it ever. It's like saying, we could entertain the idea that perhaps the Earth is at the center of the solar system, and we could still think about it and write research papers about it. So it's just something that I'm very, very serious about. I think it is not correct anymore to even entertain the concept that dark matter could ever be found. That's like believing in some sort of angels, because that there could be something, because one has oneself somehow not seen a falsification of dark matter in some way, but that is unscientific. I mean, it just is not there, the material, and it will never be found, not in 100 years, not 1,000 years, never. And there's no evidence whatsoever that there are additional particles too. So there's no point in searching for something for which we have absolutely no concept that it could exist. Maybe at an extremely high energy scale, there are additional bound states of some quarks or so, perhaps, which live for a nanosecond, as momentary states of excitation states or so, but or some resonances, but they are not going to be relevant at all for the question of dark matter. So,
well, yes, this is what you think. Some people think like you, but you know that there is.
But that doesn't matter. I mean, this is an issue of scientific integrity and the data. And mainstream is always wrong, right? And in this case, it is particularly wrong because it has been falsified. I mean, if my colleague next door in the corridor at the University of Bonn or in Charles University thinks there's dark matter, that's their problem. But it doesn't exist. And if the society considers to expend money on that, then it is bad. And that is misbehavior, because then they would have to show that the falsifications are wrong. That is perfectly legitimate. So the community would have to react, okay, we've seen these dozens of falsifications, let's show that they're all wrong. And then they would have to prove that by publication and showing that there are errors in our calculations or the errors in the other public calculations. And unless that is shown, then the falsifications stand, and then there is no dark matter. That's what we call a quantitative science. If one entertains a gray zone, then that is not physics. Yeah? And I'm very, very vehement about this. I seriously dislike this concept of there could be. I mean, we are. It's a physical science. It's quantitative, and the uncertainties. That's what we talk about: 5 sigma, 6 sigma, and 8 sigma, and therefore there is no doubt of error anymore. In particular, since we have many different falsifications from using completely different arguments, which are independent, right? So there is not a single element of doubt anymore. Dark matter is absolutely not there. Yeah, that's. I just want to make this
agree. I agree. I may agree your points, but it's not my point of view. The thing is that there is a quotation by Max Planck, I think was the author of this quotation, that says that the theories die not when it is demonstrated that something is wrong or is falsified, but when the people that support these theories disappear from science, they die or they stop to do science. So the thing is, in practical questions, we have to wait at least one generation of astrophysicists just to change the paradigm. Now it's impossible. Even if you present all the evidences, all the falsifications against dark matter, people will still think that there is something there. this is how science develops. The history of science. There are plenty of examples of this kind. The paradigms do not change just because somebody presents a new falsification. Paradigms change because there is a new generation, a new way. But we should not expect that tomorrow, in 2 years, all the community will shift to the non-existence of dark matter. This will not happen.
Well, look, I understand what you're saying, and I know that's the usual apologetic sounds which people make concerning this whole issue, but I do not accept them. And the reason why I don't accept them is that if you if you have a theorem in mathematics, then it's either right or wrong, and you prove it right or wrong, and there's no gray zone. It's not an issue of opinion that a theorem could be right or not. And this is the situation here. I mean, this is why we are talking about 5 sigma threshold. We're not talking about the 3 sigma threshold. Then I would agree with you. But 5 sigma threshold is a very hard boundary, and therefore, and since it comes from different direction, anybody who still entertains the idea of dark matter is non-scientific. That is a really serious problem which we have now in the community. And people arguing like you do now that this is because of sociology, I think that is not acceptable. I think either you understand, or not only you, but the others understand the falsifications, and then they will know that they are correct, and they will stop working on dark matter. And if they don't, then they are maybe not in the, they should not be scientists. Or as a third option, they have to show the falsifications are in error, which is an acceptable procedure. But this gray zone is unacceptable. The problem also is with the statement that the theories die out with people dying off is not true today anymore, because many of the young people are more dark matter fanatists, you could say, than the older ones, because the older ones still experience how dark matter was introduced into the sciences, so they might not be so fanatical about it. But there are young researchers when I just have to tell myself, it's better just to go away, because this is just an issue of insanity, essentially, where they are truly fanatical about this dark matter. And I've seen this many times. And that's just a total breakdown of the scientific system. And if it's so broken, then it should be stopped. I mean, why expend money for research if that is happening, you know?
We have here a second question appearing. This is a very exciting discussion for me to listen to. How do we search for unknowns? I mean, for example, in the VASCO project, in the project I'm leading, where we are looking for vanishing stars, we are looking for something that we don't know if it exists, but there we already have a hypothesis in advance. But how about if you want to look for something unknown, but you don't know what you want to look for? So what approaches to our can we use in our observations to detect something really that we cannot expect? Pavel?
Yeah, I think this is a good question, and I think it's the Galileo-Galilei principle, right? I mean, one has a new instrument, and then one looks and discovers new phenomena, and then that's a discovery of something which hasn't been known before. Or one has a prediction of a theory which predicts a particular phenomenon. For example, in Milgromian gravitation, the external field effect is predicted, which is distinctly non-Newtonian effect. And so one can go and search for that as a prediction of the theory to see whether one can show that the effect is not there in the data, and then the theory is falsified. Or if it's there, then it's clearly a confirmation of our in our trust in the theory. It's not a confirmation, it's not a proof of the theory, but it shows us that the theory has made a prediction which has been shown to be in the data, and so we continue to use the theory rather than discarding it. And so I don't think there's a particular equation or a algorithm which tells us how to discover the unknowns. The unknowns come by chance, and usually with finding developing new techniques of observations. I'm sure the other panelists have their view on this, or some can add some more.
Massimo?
I'm thinking to to the subject of our Galileo project, we are thinking, we are hypothesizing that strange things that we see in the sky can be studied scientifically using our instruments, expecting that they are the shuttles of a carrier in the solar system. Well, there could be something else. There could be something that we never suspected, something that is related to ball lightning, so some new states of matter, because there is something in some kind of natural phenomena that can simulate something like technological, but they are not. There is something in nature that could come out like a serendipity, like a real serendipity from our data. Suppose that with our instruments, sophisticated instruments of Project Galileo, we get data, all of a sudden we expect to see a flying saucer. It's not a flying saucer. It's a ball lightning of some kind made of fastly rotating plasma, which is strongly magnetized and which is emitting jets of material from the polar region, like if nature is self-similar, similar to pulsars or something. I mean, some unknown could come out from some unknown that we want to investigate, but then we find something else. This is the reason why I'm very interested in Project Galileo, because I didn't marry any theory. I've been working on extraterrestrial intelligence since more than 30 years, and yet I don't think that so-called UFOs are extraterrestrial. So this is, I'm probably wrong, but I think it's something about a new kind of physics that we have to understand better, in particularly ball lightning. So this is something that came to my mind right now.
Martin?
Yes, I don't think there is a method to find unexpected thing in astronomy or any other science. There is some randomness in the method. Sometimes we find things by chance. Just we are investigating some kind of topics, and by chance we find something totally different, which makes us discover something new. This has happened many times in the history of science. Think about the discovery of penicillin, for instance. It was produced by chance. The guy was investigating another thing, totally different, and he got contamination in some samples, and he discovered something very important. Think about the discovery of the CMB by Penzias and Wilson. They were not measuring anything cosmological. Later, they interpreted the discovery in a cosmological way, but they were just looking for some signals for contamination, for the communications, and for some phone call, whatever. So some new science sometimes are done just by chance, randomly. Of course, just working when you have to be working in something. Just if you are sleeping or you are going to the beach and not doing anything, possibly you will not find anything. But if you are doing research, if you are an astronomer and you are using telescopes and you have surveys in your hand and you examine, well, by chance somebody can find new things. There are ways to do it systematically also. Yes, as mentioned by Massimo, the serendipity surveys, for instance, just pointing to some objects by chance, just to see if there is something anomalous by chance, or just cross-correlating complete surveys and trying to find something anomalous. There are ways, but I don't think, in general, I don't think there is a method of finding the unexpected. The unexpected, as it is already said by the definition, is not expected. So we cannot make a project to find unexpected things. They will come when they come, not by surprise.
And don't you think that our biases beforehand also can influence this search for the unknowns, if we say it like that? Because the first instinct a scientist gets when they see something that is anomalous is that I must have done something wrong. And I think how How do we balance this?
I think so. There will be many self-censorship first, and then the censorship of the referees and the editors and the organizers of symposium. Of course, there will be many filters before some new discovery reaches the community. Science is a very slow process, and it's very conservative. This happens, as you say, yes.
The effect will have to be reach the 5 sigma threshold of confidence, to be taken really as a discovery. So that's basically what Martin was just saying, and to reach that 5 sigma confidence level is work, and that takes time.
If it is correctly calculated, of course, because
Sure.
there are
Sure.
I think I have read sometimes, for instance, not 5 sigma, but 3 sigma.
Yeah.
It is there are some meta-analysis of the statistics that says that at least 50% of the 3 sigma discoveries are wrong. For 5 sigma, possibly there is more confidence, but it is not Gaussian. We should not trust all the measures. There are many errors. People that do not have into account systematic errors or underestimate the statistical errors. So one has to revise again and again.
Which is why one prefers to do very independent tests for the same phenomenon, right? And if the independent tests reach 5 sigma confidence, then it's confident. And if I may ask a question to Marcelo, the ball lightnings. I'm very interested in ball lightnings. I have witnessed one. It's crazy. I mean, I was with a group of colleagues at a restaurant here in Bonn-Endenich, and we saw a ball lightning within the restaurant. It moved up the stairs. It was clearly a light-emitting ball of plasma. Apparently, the person serving the food shrieked back because, of course, you don't want to go near this. And it lived for a second or something, and then it just popped away. And so I'm very I'm confident that exists. And you mentioned ball lightnings as a possible phenomenon for UFOs. So do we know much about ball lightnings, or do you have any idea what is known about them?
There are many theories, too many theories, no unifying theory. It's considered plasma that is very compressed, very, how to say, it's attracting plasma because there is a sort of central force inside. Some people spoke about magnetic monopoles. Someone spoke about mini black holes. There is not a unifying theory about that. But I was speaking with my colleague, a mathematical physicist, Dr. Arrigo Amadori. We were speaking, what if ball lightning are a failed attempt to create universes from the quantum vacuum, something like mini big bangs that failed, and in fact they vanish like soap bubbles. It's interesting. I think we have to understand more something about the physics of the vacuum, how the vacuum and the space-time is related together, and how matter is coming out from virtual particles. This is something related to cosmology. It borders with metaphysics clearly, because if I want, I could also put consciousness inside that. But I noticed that there are many phenomena that can be explained as ball lightning, even in cases in which you see beams of light that are coming. People is telling, oh, the aliens were beaming us with a death ray or something. But the beams of light can be produced through the poles of the strongly rotating ball that is randomly moving through the turbulence of the air and emitting these things. It could be simply something, but what is the central force? That is a mystery. And this is very similar to the Stalin-like phenomena, which I am understanding. Then there are very exotic things that I don't want to make you lose your time to listen about that, but it has to do with intelligence. And maybe in the next workshop.
Shall we move on to the next question? So, how long does it take to resolve an anomaly in astrophysics? And I guess you can also reformulate the question in any way as you like and deem fitting.
Well, maybe I can start then. If well, it depends on the healthiness of the society, right? For example, today we've heard it from Avi Loeb previously and from Massimo, but not so clearly about this revulsion of the community against Oumuamua being even thought of perhaps as being an artificial object. I mean, it's just downright rejected. And anybody even mentioning that is stamped as a fool, basically. This is my reception of seeing this discussion and hearing some talks about this. And so this shows that if the society, the scientific society in the physical, mathematical sciences is not healthy in terms of being rational, then it can take forever to resolve an anomaly. I mean, people can continue believing in dark matter for eternity, right? I mean, they just know it's there. Many of my colleagues know that it's there. Even theoretical physicists. I mean, I had a pretty serious argument in the faculty recently with a theoretical physicist. He knows dark matter exists, right? And I mean, and with that unhealthy set of mind or situation of the mind, it will never be resolved. I mean, then we get down to what Martin says: you have to wait until these people die away. But the problem is, of course, they train young people to know there is dark matter, because it's a very successful thing to know, because you get a lot of research money, since your colleague also knows there is dark matter, and then it can take ages, and that's where some regulatory mechanism should exist, which just stops that process, because it's insane.
It makes me think about, just to make a little comment, about now a lot of young people are also on social media, and social media means that one brainwashes larger groups much faster. So if all young people believe into dark matter, it's going to be much more strengthened in the society.
No, I agree with you, and my argument to that would be that only weak minds use social media. I mean, why use social media? I mean, if you have a backbone, you don't need a social medium, right? You have email, and you can interact with the usual methods, but not constantly putting out these type of short statements into the ether, and that's just a sign of having not a backbone. Now, sorry to be so clear, but I think this is what the situation is, yeah, maybe the majority of scientists have weak minds these days, possibly. I don't know.
I'm just wondering if social media is going to prolong this, let's say, the resolution to an anomaly or to a problem longer.
It depends. It could in theoretically. I mean, if suddenly a wave builds up of knowing dark matter doesn't exist, it could end it fairly quickly in that sense, but it would still be unhealthy, because in the physical mathematical sciences, we cannot act on the basis of some sort of a wave of emotion, right? I mean, it has to be always rational. And so if a theory is falsified, it has to be met rationally, i.e. one has to check, is this falsification, does it stand tests? Is this falsification itself wrong or not? But we can't act on these type of Ethereal emotional waves which people put out on social media.
Unless we make them to cancel dark matter finally.
Yes, well, that would be. No, but still, that I think that would not be the right.
What does Massimo and Martin think?
Should I first? Yes. About dark matter, as I said, I have not said it's one generation. Maybe it's many generations. So it's true now that the young people are even more stubborn than the previous generations, and even more difficult to discuss with them. I agree, but maybe we have to wait much longer. If we examine the history of science, again, I insist in the history because we have a lot of lessons to teach. to learn from history. There are some discussions, some anomalies, some tensions in science that can be taken very long time, many generations, even centuries. No, it's not. There is not a magical way to solve the things quicker. I do not agree totally with this idea of Pavel that science is something totally rational and free of passions and free of attaching to some prejudices. No, science has prejudices. Maybe not in mathematics. Mathematics is an exact way to demonstrate the things, and you can demonstrate the things. But physics starts to be somewhat contaminated. And if you go to some topics like cosmology, in particular, there is more elements, irrational elements, prejudices, cultural things that are invading us. And well, this is the dynamics of our society. We cannot change the nature of human beings. We are irrational, and I'm not surprised that even if there are enough evidences, as Pavel says, that the dark matter is a crazy idea, even if it is that, I would not be surprised that still 1 or 2 or 3 generations more of people will believe in that, and at least until there is some important change in the economical and political system. Usually the changes in the structure of our society. Now we live in a capitalist epoch in which science is produced in a capitalist way. You have to invest a lot of money in very expensive particle accelerators, and there is a lot of interest of people to maintain the illusion of dark matter. But this is how it works. Science. In the moment in which the science is produced in a different way, just because a new change of system, or imagine that in the future, well, the Western civilization disappears and appears a new civilization with new ways of seeing the things. Possibly there will be new paradigms also. So we have to bear in mind that science is not pure reason. Science is not pure mathematics. Science has emotions. Science has people that have been investing 20, 30 years of their lives in a theory, and they are not going to abandon it so quickly. They will try to invent new patches and new ad hoc solutions just to keep the inertia of what they have been doing.
Well, I'm afraid I take a different view. I'm a purist in that sense. Science must be rational, otherwise it's not science. So if you entertain the idea that there's this gray zone, then that's not science. Sorry. I mean, there's just no argument.
I wish science to be rational. I'm not supporting.
No, you should not wish it. You need to demand it, Martin. I mean, if you are teaching young people to do science, then it is a demand. It is not something you can say it could be there. I mean, in mathematics, when you educate students, you can't say that there's a gray zone around the theorem. I mean, it's clear cut. Either it's true or not, and the proof has to be completely logically true, right? And in the physical sciences, is exactly the same, except that we have measurement uncertainties. That's why we have confidence limits. And within that, it has to be rational, and there's no gray zone of having some sort of beliefs. It is not. Otherwise, it's metaphysics, and we must not entertain the concept that it's metaphysics, because then it has to be thrown out of the funding agencies. Yeah, so I'm very strict with that. There's no pardon here at all.
You are right, but let's see what the science evolved.
As I'm saying, I mean, close it down. If it can't become rational, close down the sciences. There's no point in expending money for something which is not what it should be. That's just the way it is. I mean, either the scientists learn to do it properly. And by the way, you said, it's been like that always in the past. I disagree. I mean, we have never had the type of crisis we are having now, never in the history of humanity, that the majority of scientists have gone crazy on some idea to the point of disregarding evidence. That has never happened in the history of science. With so many highly educated scientists going so completely off track, it's a completely new historical event. Maybe it's related to the social media. I think it's related to the concept that it's grants and prizes which drive science. but it is definitely completely wrong. And I'm only saying the alarm clock should be ringing to those who give taxpayers' money to the scientists, because the scientists are failing on a very major front at the moment. Yeah.
Think about the idea of ether in the 19th century. Was very supported by the.
No, it was a different time. You had 10 people in the world thinking about this because only they were the physicists who were educated. Today you have thousands of people. And we have much, and we have all the experience from the past. We have the ether experience. Therefore, we should not repeat the ether experience, right? I'm sorry, I don't see any excuse in that at all.
Massimo, do you have any comments?
Well, I have to say one thing, that when I wanted to become a scientist, I thought that would have been a higher level of society, in the sense of critical thinking or something. Instead, what I discovered that the people there are too human. It's also the title of a science fiction novel, Too Human, too gossiping, too attained to a belief system. I know everything about stellar evolution. I don't need to learn anything. For instance, during my PhD work, I discovered that some stars are emitting, creating mass loss in a closed binary system in a pulsating way. I discovered it from its spectra. No, they were telling, no, everything is very well known. Mass loss is continuous. Clearly, they invented the continuity in mass loss because it was making calculation more simple. Okay, or stellar structure. Why not putting magnetic field intensity? Why not put magnetohydrodynamics? Because it makes calculations more complex. Okay, so we practically study a map and not a territory, and we are making something very epistemological but not ontological. And when it's time for studying high energy phenomenon like the Stalin phenomenon, which is an enlarged version of the ball lightning, everyone is hiding the head under carpet. They're throwing practically all the stone under a carpet until the carpet become a hill and then a mountain. Okay, they have not the courage to go forward and say, take the instrument and measure that. We can do that because this phenomenon can produce a lot of energy, which can reproduce in our laboratories. No, they don't, because they live on gossips and they're saying, oh no, I cannot do that because then my colleagues say that I study UFOs, because there are these people that then there are ufologists that try to exploit scientists, telling, oh, he said that. So there is some gossip, there is too much human emotional, too much belief systems, also in people who claim to be rational, and they are not. So we have to be, how to say, full of, out of prejudice, aseptic, really aseptic, try to be that. Okay, this is something that came to my mind thinking to your question.
All right. This has been a fascinating conversation, and I wish we would have allowed more than 30 minutes for it. At this point, we've been out here for 40 minutes, so I do have to close this session. So I want to first begin by thanking Beatriz for chairing the session. It was a lot of planning went into bringing together these speakers and this program, so thank you very much.
Thank you to you.
I want to remind everyone that the SSE, we are here to provide a professional forum for those topics that are ignored or studied inadequately within mainstream science. And with that in mind, I'd like to encourage those of you here today who are not yet a member of the SSE to consider joining. I think we've dropped a link in the chat. Now, this official symposium is closing, but we are still going to keep the social lounge open. I will keep it open until the last conversation has ended. So everybody is welcome to stick around and to continue the conversation for as long as you wish. But for now, we must say goodbye. Thank you again, gentlemen. Thank you, Beatrice. And we'll see you next time.
Thank you all.